All right, this video will give an overview of Lesson 1. We've already covered some of these features or the introduction to this lesson. So last class we started looking at this general shape of a curve here. So we had the motorbikes going over a ramp. We had the basketball being thrown, the ski boarder or snowboarder. So we've done a lot of those things just describing what we would call projectile motion, objects being thrown. And we'd also say, well, it not only applies to objects being thrown. So we don't only look at projectiles, but we can talk about natural events, such as, and we ended the class here, the rise and fall of the tide. So if we were to plot the rise and fall of the tide, that at 9 o'clock the tide was, well, this is 0.8 meters. So let's say that's going to be maybe about 0.9. And then as time went on, each dot represents the height of the tide. And if you connect the dots, well, again, you get the same smooth curve. And remember that we said this was what we would call a relation. And it's a special type of relation, function. So what we mean by relation and function, just to review those ideas, is that a relation is something that connects two different quantities or two different values. So here we're connecting time and the height of the tide. As time passes, the tide rises, and at a certain point it starts to fall again. A special type of relation is a function where, if you look here, one time can only give you one height of the tide. So at 9 o'clock, the tide can only be this height. It can't be here or somewhere else. Versus when we looked at the example in class of comparing a student's height with mass, you could have two students with the same height, but have different masses. So this would not be a function. It is a relation, but it is not a function. Over here, this is a relation because there's a relationship that exists, and it is also a function. You can't find a time here on this graph where the tide could be at two heights. Now you could find a height that's two times. So if you look across, say at 1.2 meters, you could find two times. And that's allowed. All right, you can have the points horizontal, but you can't have them stacked on top of each other. So what this results in is that, let's say this is, I'll make a value, let's say 915. So we state the x value first, and we'll give a height of 1.2. So this will be our time going across, and this will be our height. And the other one, well, you could have a time of, well, let's say here, at 1400 hours, and height of 1.2. So the heights could repeat, but not the times. And we'll spend a little more time on that later. So what we have here, to reveal all the mysteries, what we have is something called a parabola. Okay, it's a U-shaped graph. So a special name, and we'll refer to it as a parabola. So this shape here, and again, bike, they're all parabolas. Another word you might hear for that is a quadratic. So what makes a parabola? How do you get the graph out of that? Well, we're going to skip past this little section here and come back to it. And I'm going to ask you to make this graph here. So this is on your sheet that you have. And just let me get my highlighter back. Here we are. So I want you to graph this. So y equals x squared. So in order to graph that, you take these x values here, and to get the y value, you have to square each of them. So take each of these values and square them and place them here. So you can pause the video and see if you get the values right. And I'll continue. I'll assume that you've paused it and now you've started to back up. So get my value here. I'm taking -3 and squaring it. So I get 9. If I take -2 and square it, I get 4. And again, that instruction comes from right here. And it's telling me to get the y value, take the x values and square them. So we have 1, 0, 1, 4, and 9. And what you notice is that the values repeat themselves. So let's plot these. So you now have ordered pairs. So we had mentioned that in the previous class. And an ordered pair is having an x value and a y value. So you always list your x value first. So -3, 9. -2, 4. -1, 1. 0, 0. We have 1 and 1, 2 and 4, and 3 and 9. And so I want to point out here is that your x values never repeat themselves. The y values can repeat themselves. So for instance, you have 9 and 9. You have 4 and 4. Y values can repeat. X values are never allowed to repeat. So you might want to make a note of that. The x values never repeat. You might want to think about why that is. Okay, so plot these. So you go -3 and 9. So I go over to -3 and up 9. That will put me here. And I have -2. Oops. And I'm assuming, of course, you've already graphed this. So -2 and 4. -1 and 1. 0, 0. And then what you notice that the values the heights start repeating. So 1 and 1, 2 and 4, 3 and 9. And if we were to connect them, here we are. So what makes a quadratic, or makes a bend in a line, it's having a square. When your exponent is a 2, that causes a quadratic. So that's the condition. So that condition here must always be met. Is that in order to have a quadratic, your highest exponent has to be a 2. So the highest exponent, so another note you may want to put in here. Well, let's say biggest exponent. Let's not just say exponent is 2. So when you think about writing up your summary sheet that you're allowed to use in class, you might want to make notes on that. So the biggest exponent, or power, the biggest exponent, EXP exponent, is 2. Now some features of this. So yeah, we do have a bend. The graph also has what we mentioned last class, a line of symmetry. It's symmetric. In other words, you could cut this graph in half. And the line of symmetry, if you're seeing it now, think of it like a fold point. If you were to print this off or take your paper and put a crease in it, you could match these points up. That this here is what we would call an axis of symmetry. This yellow line is what we would call an axis of symmetry. So it's a point around which one side is the same size as the other. And if you just take a note here, like look at this point. How far away is this point right here from the axis of symmetry if you had to go straight over? Well, it's 2 blocks, or 2 spaces. This one here is also 2. And up here, this one's 3. That one's 3. And 1. And 1. It's symmetric. So all the points line up. Until they get down to the very bottom. And let me get a different color here now. And at the very bottom here, they merge. The 2 sides of the graph come together. So if you trace down on the left side and on the right side, the graph comes together. And that gets a special name called the vertex. And that's the point at which it comes together. So your vertex is 0, 0. It won't always be 0, 0, but in this case it is. Okay. So let's come back up here. So when we spoke about the highest exponent, right here, highest exponent is 2. That's also referred to as the degree. So this idea of the highest exponent being a 2, in math, another way that's described is by saying the degree is 2. So if someone speaks about the degree of a function, they're speaking about the highest exponent. So we'll just add that in there. Okay, so there's a couple different versions of this we're going to look at. And I'm going to open up a separate program here now in a moment. But what we're looking at is something called standard form. So I'll pause it here, and I'll switch screens. All right, so what I've done now, I've opened up my web browser. And here at the top, I'm at a website called Desmos. So if you go to www.desmos.com, there's a link there that says graphic calculator, and it brings up this grid, and you can type in equations here. Now there's an option here to log in or sign up. I just log in using mine. You don't need to, but I use my district Google. All right, so let's talk about what we just had there. Y equals x. And to get an exponent, if you push the Shift and 6 key, there. Now, but that's not the only thing you can do. What if I just say 3x? What if I just had an x variable there? And what if I just had a plain number? So there's some different things you can do here with this. So it doesn't have to be just x squared. You can change some of these values. And we're going to spend some time exploring what happens as you change these. So I just want you to have this idea that you could have x squared term. And we would call these terms, there's 3 different terms. X squared, you get an x and you get a plain number. So I could have an x squared. I could have just an x. I can have just a plain number. So really, what that is, we would let the letter A, and I don't think this is a graph anything for us. We'll go back to our notes in a minute. We have the letter A stands for whatever number is in front of x squared, and there's no restrictions on that number, except it can't be 0. Because if it was 0, if the A term was 0, it'd be 0 times x squared. And then you wouldn't have a quadratic anymore. Because to have a quadratic, you gotta have x squared. You could have B. And then a plain old number is just titled with C. And what you see pops up here, add a slider. A, B, and C. So what happens is we adjust the A value. And let me get rid of my first graph there. And this is what I'd like for you to do. as you adjust the A value, what happens to the graph? Oh, and I've done something really weird there. So what happened there? And when did it happen? At what point? So those are questions you're going to want answered. B, as you adjust the B value, what happens to the graph? And if you're trying to pick the vertex, and look what happens to the vertex. So if I put everything right back, oh, now I made the A 0. What happened there? So I'm going to ask you some questions I want you to answer. So what happens to the graph here? And the C value. What happens there? So I want you to type in this equation in Desmos. Y equals ax squared plus bx plus c. So let's just start that over. And it says add slider, so add all. And what that means is it's going to let you adjust these values. So I'm going to ask you some questions. So I'll have a Google form there. What happens is you change those. All right, so I'm back here at the notes now. And I want you to, and we're going to answer these questions here. So which of the following are quadratic? So we want those answered. And a lot of these points here that we also talk about now, I'm just going to scroll through it because you'll ask some questions about this later. We'll pick that up in class. And it does summarize some of the things that you need to know. Okay? All right. Thank you, folks.